Now that we've been introduced to what entropy is, we're going to do some practice problems that deal with calculating entropy and making some predictions. So in the last video, I showed you that there's a mathematical expression for entropy, and that is S equals K ln W. K is the Boltzmann constant, which is the gas constant, 8.314 joules per mole Kelvin, divided by Avogadro's number, 2 times 10 to the 23rd, and that would be that's per mole. So our Boltzmann constant is 1.38 times 10 to the negative 23rd joules per Kelvin. So, and remember that W, this is our microstates, and so it's unitless because it's just a constant, it's just an integer, it's a number. So it should be pretty obvious that as W goes up, S also goes up. So let's revisit our phase changes. So we're going to imagine water melting. So we're going to go from H2O solid to H2O liquid. This happens at a constant temperature of 0 degrees Celsius. So we can think of this as a reversible process because we can think about this as an infinitesimally small addition of heat causes more melting, and an infinitesimally small removal of heat causes more freezing. And so at 0 degrees, it's possible to imagine this as a reversible process. So let's take a look at this. So we can use our delta S is equal to Q of the reverse process over T. And so we're talking about the heat exchanged with the system and the surrounding, so the heat exchange during a reversible process. That's what Q reversal means. Okay. All right. So at a constant temperature. So we have a constant temperature of 273 Kelvin. And we know the delta H of fusion, which is the delta H associated with ice melting. And so we go from Q equals delta H of fusion, which equals 6.02 kilojoules per mole. All right. And so then we can plug it into this equation. Delta S equals 6.02 times 10 to the third joules, right? Because we got to switch kilojoules or mole, divided by 273 Kelvin, and that equals 22.1 joules per Kelvin. So you'll notice that this is a positive value, which we expected, because remember we said if we go from a solid to a liquid, that is a positive change in entropy. Here's another practice problem. So we are talking about 100 degrees Celsius, which means that our temperature is constant. So we can go ahead and keep using that same equation. Delta S equals Q of our reversible process over T. So we need to have the necessary information. Okay, so what we're going to need to know is our heat of vaporization and condensation. That is the heat of our phase changes. So delta H of vaporization, which is the liquid to gas, is 40.7 kilojoules per mole. And the delta H of condensation is going from gas to liquid, and that is negative 40.7 kilojoules per mole. Again, same value, same magnitude, opposite sign. All right, we have to go into Kelvin. So we are at 100 degrees Celsius. So 100 plus 273.15 is 373.15. Okay, so we're ready now. We are going from a gas to a liquid. So that means that we are condensing. So we have to go with delta H is, so it is negative 40.7 kilojoules per mole. And we have 25 grams, so we have to convert that. Okay, so we've got 1 mole per 18.02 grams times 25 grams. And this whole thing divided by our temperature of 373.15 Kelvin, which gives us a value of negative 151 joules per Kelvin. So is this what we expect? Well, yeah. If we're going from a gas to a liquid, then that means that our entropy is higher in the gaseous phase than in the liquid phase, and we see that our value is negative, which we totally expect for this process. We can also predict the sign of delta S without worrying about the actual value. So for example, if we have a mole of liquid water and it's at 25 degrees, and we're taking that same mole of liquid water and increasing the temperature to a mole of liquid water at 50 degrees, then we would have to predict our sign there. Well, we are going to see that the sign of delta S for that is going to be positive, because our atoms are going to be able to move around a lot more. For the Ag aqueous and chloride aqueous, we see that we're going from 2 compounds down to 1 compound, so our entropy there is going to be negative. Going from calcium carbonate solid to calcium oxide solid and CO2 gas, not only are we going to 2 different compounds, we're also going from just 1 solid to a solid and a gas, so that would be a positive entropy.